Alright guys, I think I'm going to discuss one more example on the variation of parameter. So if you can look at the questions from past year test 2, you have 4 questions, but I'm going to just explain the solution for problem number 2, because I think problem number 2 is quite tricky, not quite straightforward. Even the integration that you will see later is not that straightforward. Okay, so let us see problem number 2. Okay, so I can rewrite the expression of our ODE as y double prime plus c square y equals secant square cx. Okay, and given that c is a positive number, c is greater than 0. Okay, so you may want to highlight that part, okay, because it is very important. And first of all, okay, we want to find the constant c. Okay, if the Wronskian somehow is stated to us, W is 3, okay, the Wronskian is W. So once we know what is the value of C, then we can proceed with the further steps, okay. If you do not get the C, then most likely you will not get your final answer, because the solutions pretty much depends on the value of C, okay. So first of all, we want to find the YH. Okay, so we want to get the Wronskian. Okay, so the characteristic equation is m squared plus c squared. Okay, c is a constant somehow, but positive value. So we have m squared plus c squared equal to 0. Okay, so don't get confused with the c. So c is constant. So it's like you have m squared plus 4 or m squared plus 1. So m squared is actually negative c squared. Okay, so you will have m, which is the complex form. So m1 and m2 is actually the square root of negative c squared. So this is actually the square root of c square I squared. Okay, so we'll have m1 and m2 can be written in the form of 0 plus minus what? Ci. Okay, so we have complex root here, therefore our YH is then to be exponent 0, okay, exponent 0x, okay, we don't write that one, and then we have a cos, now the imaginary part is C, so it is Cx plus B sine Cx as well, okay, so we have that one. Okay, so based on this YH, again, we need to write our Y1 and our Y2. So the first term is A cos Cx. So we ignore the A. So we have cos Cx. And then we have the sine Cx. Okay. So then we can form our W. Okay. So W is then Y1, which is cos Cx. And at the bottom, we have the derivative of cos, which is negative C sine Cx. And y2 is sine Cx, and the derivative of sine Cx is C cos Cx. So careful, you have C and another C for the cos. So carefully when you write the C and also the cos. Okay. So it is stated that the value of W is 3. So it is given to us here. So we use that information. So it means that, okay, the process here, the C cos square Cx, okay, minus with a negative C sine square Cx is 3, okay, which comes from this one. So we can see that we have C and then cos square Cx plus sine square Cx, which is 3. Okay, so you can see the expression in the bracket is actually the identity, the trigonometric identity, cos square A plus sine square A, which is 1. So this is actually 1, regardless the C here, okay? Because we have cos square plus sine square with the same angle, Cx, and this the same angle Cx. So it means that our C then is 3. So that is our C. I want to show you what goes wrong to some of the students, okay? So some student, okay, write the YH, okay, so I'm going to show what are the mistake that has been done previously by the student. Okay, so some of the student write YH as A sine CX plus B cos CX. Okay, this is correct. Okay, you can swap, okay, which one to be the first term. Okay, so when you have YH in this form, so most likely, okay, you will write your Y1 to be sine CX and your Y2 equals cos CX. Okay, so based on this, okay, so the student will write W is then sine CX. The derivative of sine is C cos CX. And somewhere here is the Y2, which is cos CX. And the derivative of cos CX is negative C sine CX. And given by the problem, the value of W is 3. Okay? Okay, so if you proceed further, then you will have negative C sine square CX minus C cos square CX equals 3, which is now negative C. Then you have sine square CX plus cos square CX equals 3. So you know this is a trigonometric identity, which is 1. So you will end up with negative C equals 3. So you will tend to write C equals negative 3. Okay, so what goes wrong is actually here. Okay, because it is stated that C must be positive. Okay, so this is where you need to look carefully. Okay, there must be a reason why the problem stated the value of C should be positive. So if you end up with something like this, then you know this is not the correct YH, even this is not the correct way to get your C. Okay, so you should switch, okay, your first term of YH and the second term of your YH. Okay, so I hope you're clear on that, and then we can proceed further. Okay, okay, I'm going to wipe this incorrect solution here before we proceed to the UNV. All right. Okay, now once we know our C, okay, then we can get our U. Okay, so U is the negative, don't forget, okay, the negative, so the integral, then Y2, our Y2 is sine, okay, CX, since we already know C is 3, so write directly sine 3x, okay, times the fx, okay, so our fx is secant square CX, so C is 3, so 3x, over A is 1, okay, and W is 3, so we write over 3, so dx here. Okay, so we end up with a negative, okay, 1 over 3 can be put aside. So we have the integral of sine 3x times secant square. Okay, so secant square is actually 1 over cos square. Okay, so we end up with a tangent 3x secant 3x. Okay, because 1 of the secant is 1 over cos, so we have sine over cos, which is tangent. Okay, so we have this. Okay, so many of the students stuck here. Okay, do not know how to solve tangent 3x and secant 3x. Okay, so you must use the given formula. So if you can look at the list of formula, so you have somewhere here tangent, secant x, tangent x dx. Okay, secant x, tangent x dx. Okay, the integral of secant x tangent x dx is secant x. Okay, but it's slightly different. Okay, the term that we have is slightly different in such that we have secant 3x tangent 3x. Okay, so our answer is supposed to be secant 3x, but then we need to differentiate the 3x. Okay, so go back to the solution. Okay, so for this one, we will have negative 1 over 3. So the answer would be secant 3x, but don't forget we need to differentiate the 3x so that we have over 3 over here. Okay, so plus with the sum constancy, so that is our U. The same thing goes to the V. So V is the integral of what is that, y1, so we have cos 3x, and then fx is secant square 3x, okay, over again the same thing, okay, dx. Okay, so now here we end up with a cos 3x times 1 over cos square. Okay, so we have here actually secant 3x dx. Okay, this is also given by the table. Okay, the integration of secant x dx is ln secant x tangent x, but we have secant 3x. So the answer should be, so we have here, okay, so we have 1 over 3. So we have 1 over 3 here. So it is 1 over 3, then the answer should be ln, okay, secant 3x plus tangent 3x. But don't forget, we need to differentiate the 3x so that we have over 3 somewhere here. Sorry. Okay, so somewhere here. So you have the bracket over here plus with the constant d. Okay, so with that, u and v. So at the end, you can write your y, which is u y1 plus v y2. So I hope you can write on your own for this one. Just put things together. So you will have your y. Okay, it's your final answer. What I want to highlight is how to get the c and then how to solve the integral that you have in u and v. Okay, I hope you can proceed on your own. Okay, take a few minutes to digest the solution here. All right.